So thank you for taking the time to join our webinar today. My name is Chad Collett. I'm founder and CEO of SubC Imaging. I'm going to present an evidence-based approach for showing the applications for our solutions. So we'll start with a quick company overview, very quick, and then go into some solutions and their capabilities, followed by a product demonstration and then some videos of scientific studies. We're an underwater company who develops advanced imaging solutions, essentially. That's the short and sweet of it. We have clients all over the world in every continent, working in every ocean, from the United States, Iceland, Brazil, and Japan, and everywhere in between. We have agents worldwide, and this list is growing every month. If you are doing a project, there should be someone roughly in your area able to talk about it. So here are some solutions and their capabilities. We have a subsea digital stills camera solution, which takes digital stills in sync with LED strobes. In this picture, you can see a lionfish, and you can actually see the ROV's reflection in the lionfish's eye, which shows you the resolution of it. We can also record 4K and HD video clips to the cameras and stored to 512 gigs of solid state memory. In this picture, it's an ROV, picture of an ROV taken from another ROV. Our cameras include auxiliary ports on the back for plug and play control. So they allow quick interfacing onto underwater systems and reduce the cost and complexity. Reducing cost and complexity is one of our common design goals at SubC. We also have solutions for full ROV surveys, which include topside recording and overlay systems. These are for recording video, audio, and data from sensors for later cataloging and review. They have 6 channels of video input, and on each channel you can overlay dynamic graphics, text, logos across each one. In this image here, you can see this is heading, as well as you've got your altimeter, depth, and GPS location, and a logo. These solutions are compatible with IP cameras, SDI, and composite video formats. All video formats and resolutions up to 4K are supported. We have an autonomous camera solution that runs on battery power for time-lapse stills and video. For most autonomous systems, of course, you're running on battery power, but it also works without a battery. Our cameras execute their own scripts so they can run completely autonomous. This is a system that one of our clients set up for doing natural behavior studies of fish. They used red lights so that the fish and species couldn't see the light as they were being filmed. Our camera systems are also data loggers, so you can pipe in live data from other sensors, such as CTD, gyro, altitude, etc. The cameras include tilt and roll, and we have an option for built-in depth sensor as well. We're working on a new drop tow camera system with a number of goals for the system, one of them being lightweight and deployable from small watercraft. While being also lightweight and relatively low cost, it also records HD and 4K video with digital stills in sync with strobes. And it provides real-time video to the surface for monitoring as it's being towed. We have an observatory imaging solution that is in use worldwide, and the cameras directly control the LEDs, lasers, and pan and tilts and other sensors, so thereby reducing equipment cost. Our builds are in full titanium for corrosion prevention. That's our standard, is all titanium builds. And our cameras include water-corrected on-off optics designs, which give really high-quality imaging and negate the negative impacts of water. We have a new video and data streaming service that we are developing and releasing next month. And the purpose for this is low latency, secure, very easy startup live streaming video. And this is particularly relevant these days because we're all working in a remote world. We've always been working remotely, but now even more so. Instead of ROV to ship, this is ROV to shore. And I'm going to give a quick product demonstration now. So this is real-time video from one of our cameras running, sort of remotely. It's in another room here at SubC in our tank. And you can see that the general theme that I'm going to talk about here is ease of use. Everything for controlling the camera is at your fingertips. So this is particularly useful for offshore science because everyone has a job to do and is there to collect data, and you don't want to be struggling with the equipment. So we've done a lot of work and spent a lot of time creating an easy user experience. So here you can see your depth, heading, tilt, and roll, built-in sensors, all of your exposure controls along the top, auto and manual. You can change your exposure settings. You can also change your focus. Your recording time remaining and your photos remaining are displayed. And that changes dynamically based on your recording type. You can change your file naming structures and your directory where you're saving that. All of this footage is saved onto the camera, and all of the footage is real-time accessible while the camera is running. So you don't have to interrupt your project or your survey to review your footage. You can see it in real time. As you take a photo, it creates a thumbnail that is put up in the top corner, and you can review that in real time. You can zoom in on the photo, check for good focus, check for good exposure settings, retake the photo, change your exposure settings, take the photo, and you'll get the new setting. It also has built-in strobe synchronization with the exposure time and real-time control of the lighting. I spoke about plug-and-play devices. So you can actually plug in different equipment to the back of the camera, and the camera will control it automatically. So if I put the lasers up, I get controls to turn them on and off. If I remove the lasers, the control disappears. Same with LEDs, and the same with other devices as well. We can integrate new devices over time, and we release software updates. They're about quarterly is about our schedule right now. The camera runs an API. You can see the API in real time, and you can write scripts for that API. We have separate tutorial videos on how to do those functions, and this software includes our web streaming, which I briefly spoke about previously. And that concludes the product demo, so I'm going to go back to the presentation. So I'm going to show you a few videos of example scientific studies that our clients have completed. So Woods Hole Oceanographic Institution, WHOI, set out to sea for 3 weeks on the RV Atlantis from Gulfport, Massachusetts, equipped with the newly redesigned Alvin. This was a couple years ago, and the autonomous underwater vehicle Sentry as well. And they visited some of the most spectacular Lophelia reefs known and explored the deep sea for new reef habitats. Corals were collected and kept alive in order to determine if some of them are more resistant to ocean acidification than others. And this may help preserve the Lophelia reefs in the future by identifying some resistant strains of deep sea corals. So this video was used in the Acid Horizons documentary, which won some awards at film festivals back in 2018. The link to the site for the documentary is in this slide. And if you search for Acid Horizons on Google, you'll find that as well. Just bear with me here. Okay, technical difficulties. A subsea camera and LED were included in a Marine Institute study of one of the longest living species of shark. This study was conducted by Bryn Devine and Laura Wheeland. Our friends at Marine Institute gathered 258 hours of footage as part of their research to estimate the local densities of Greenland shark in deep water and data poor regions of interest for fisheries development and marine conservation in Nunavut, Canada. The results of this study illustrate the potential vulnerability of the Greenland shark and that Nunavut's Lancaster Sound ecozone may be of particular importance for this species as well as many other Arctic species. Switch back to the presentation now, just bear with me. Shoot, 1 second. Okay, so what WHOI, Woods Hole, use our cameras to film lava tubes in Hawaii. So what are lava tubes? Lava tubes are tunnels that form within lava flow during an eruption. As lava flows away from a volcano, surface chills quickly and insulates the still molten lava beneath. Rivers of lava can continue to flow for great distances in the tunnel beneath the chilled and solidified surface before it cools and becomes hard rock. It creates some fairly interesting looking structures on the seafloor. As the eruption slows down and lava stops flowing, the molten lava drains from the tube, leaving a hollow cave inside. These tubes can be several kilometers long and many tens of meters in diameter. They can range in size, of course. The Thurston lava tube near the caldera of Kilauea volcano in Hawaii is famous. That has been a tourist attraction since the 1800s. On land, they form a fair bit different than underwater, but our focus is obviously underwater. So here are these. Back to full screen. So we have a number of solutions, as I spoke about, from ROV through to autonomous and drop camera and observatory type applications. And that's what we do. That's who we are at SubC. So if you're interested in learning more about us and how we can help your application, check out our website, email us at team@subc, or give us a call. We're here to help. Equipment is available to purchase or rent, as well as trials for your projects. And we'll go into a Q&A.
Chad, what is the runtime of your camera? Len is asking.
Runtime. The runtime depends on your application. So do you mean in a battery deployed application, or say an observatory type application?
Let me see if I can turn Len on.
This is Len Zabalansky from the OMSAT facility. Very interesting presentation, as we're always trying to take better pictures of subsea testing of oil recovery systems. The question was, autonomous operation in a battery environment is how long can your system run?
So you'd be limited by the battery. The camera's max runtime depends on the quality of footage, but I believe if you want an SD quality footage based on the encoding rate. It can record for 208 hours. I think that's about
Okay.
6 days. But at
That's
4K,
that's longer than I get. That's longer than I get the technicians to work.
So as long as you want, basically, based on storage capacity.
That's good. As long as it's more than 8 hours.
More than 8 hours for sure.
And the other nice feature is your real-time display, so you can actually see what the camera's looking at.
Absolutely.
Because using the GoPro, we're shooting blind.
Yeah, so that's that's an alternative for sure, and it's the way most research, marine research, kind of starts off, and then you go down that path and you start to find the limitations. It works for some studies and it doesn't for others, obviously. So we're here to help in the cases where you need something better, something different.
Thank you.
No problem.
Okay, thanks, Len. Any more questions? If anybody wants to pop into the chat box there, I can unmute you if you want to do that, or just type in a question. Are all the cameras also data loggers, Chad? Jane
Yes.
Delgado has asked.
So we have two types of cameras. One is purely live feed, and that's where you get your optical zoom and your live HD or 4K video. And then we have our digital stills 4K encoding cameras that also offer a live feed. So you can have live feed in both, but one records, essentially.
Okay, well, I guess if we don't have any more questions, we can wrap up and everybody can get back to the conference. Is there anything in closing you wanted to say, Chad? How do folks get a hold of you? Any projects you're working on currently that are good demonstrators of your technologies?
Yeah, sure. We're working with a number of organizations on projects we can and can't talk about. So one of the ones we can talk about is the hopeful Titanic expedition with OceanGate. They've been working on going back to Titanic to do this kind of extreme tourism, but also mixed science as well for the last number of years. So we're involved with that. And again, we're happy to work with you on your projects as well if you're listening. We're open to collaboration. We're open to discussion. We can do custom design, custom engineering, and we also have some ready to go products as well for different projects. So you can get us at you can reach us at team@subseaimaging.com, our website subseaimaging.com, and our phone number is available there as well.
We have a question in the Q&A. Is it possible to get a copy of the presentation to show colleagues? From
Absolutely.
IOSHA's perspective, we've recorded this, so we're going to edit that and post it up for you to watch, basically a video of this presentation. But Chad, what kind of materials can they get from you besides rewatching the video?
Yeah, we can put this presentation on FTP and send out a link, and it's as a PDF. And if you email us, we can also send you a direct link.
All right. Well, I guess if there's no more questions, we'll go ahead and wrap up. And thank you for everybody for joining.
Okay. Thank you for your time, everyone.